Solve the simultaneous equations below using a matrix method. So we've got 4x plus 3y is 6 and 2x minus 5y is 16. So the first thing I'm going to do is make up a 2 by 2 matrix containing the coefficients. So 4 and 3, and then 2 and negative 5. I then have x, y. Just try doing the multiplication. You get 4x plus 3y on top, 2x minus 5y on the bottom. And so if we put that equal to 6, 16, that is the simultaneous equations represented as a matrix. Now, what we want is the inverse of this matrix. So the determinant of this matrix is going to be 4 times negative 5, negative 20, take away 6, so that's negative 26. So the inverse for the matrix would be negative 1 over 26, negative 5, 4 by swapping the leading diagonal, and then negative 2, negative 3. Now what I'm going to do is multiply that by 4, 3, 2, negative 5, x, y. And since I've multiplied the left of the equation here by the inverse, I of course have to multiply the right hand side by the inverse. Now, because these are inverse matrices, that's just going to become the identity. And then over here, we've got to do this matrix multiplication. I'm probably going to use the calculator to help with this. So if we use the top row, we've got negative 5 times 6. So negative, use the wrong negative. I do that a lot. So negative 5 times 6, take away 3 times 16. That gives me negative 78. And then here I've got negative 2 times 6, add 4 times 16, and that gives me 52. And so that's x, y, this side's just x, y because that's the identity, is equal to 3 and negative 2. So we've got x equals 3 and y equals negative 2. So if we look at this one, we get 2, negative 3, negative 6, 9, x, y equals 9, 7. Now when we look for the determinant of the matrix, we've got 2 times 9, take away negative 6 times negative 3, which is 18, take away 18, which is 0. So actually this is a singular matrix, and therefore we can have no solution because we can't find an inverse. In actual fact, if you look at these two, they're parallel lines.